We are going to do 16.2, angle relationships in circles. You can see my whole board full of circles. And we're going to work with angles. Angle 1. You can see all my angle 1s that I've indicated. And we're going to measure them. What's the measurement of these? We're not going to physically use a measurement but we're going to determine it. Right, with the intersecting chords, angle measure theorem, we're going to see chords clearly. A chord intersecting a chord, we want to know what is the size of this angle. And there's a theorem going. This theorem says that if I want the size of this interior angle right in the circle, I'm going to say a half of, and I'm going to use color so that we can clearly see what we're doing. And in this case, a half of this arc measurement, so the measure of the arc from A to C. There's my arc from A to C. And I'm going to add, in this case, the measure of the arc from D to B. The measure of the arc from D to B. And there's my formula. If I want to calculate the size of this angle 1, I get the measure of this arc plus the measure of that arc, not the top and the bottom. See, opposite the 1 and opposite this on the opposite side, and I add and I take half of this. Your answer can be divided by 2. And you will know the measure of angle 1 when I have 2 chords intersecting in a circle. Intersecting chords, angle measure theorem. Add the 2. If they want you to calculate this angle, then you'll add the top and the bottom one and half of that. Okay. Next, the tangent secant interior angle measurement. Here we have a tangent. It's only touching the circle. We have a secant. It's going right through the circle. And I want to calculate angle 1. It's the interior one, so my angles must be in my circle. Interior angle measure theorem. And if I want to do this one, we're going to say half again. You'll see every time there's a half. I want to put in my half here already. Every time a half. And in this case, we're going to say half of this arc that subtends the angle. So it's half of the measure of the arc from A to B. There's my arc. Now here we don't have a tangent and a secant. It's a secant and a secant. But you can still call it tangent secant because we have the interior. But if you call it secant, interior angle measurement, that's also okay. And I must get half of the arc measurement AB. The measurement of AB arc. And you can see the angle is lying on that arc. The angle is lying and it's included with that arc. And now no adding or subtracting, just half of the arc, half of the arc. This is the easiest one, the interior angle measure theorem. The last one we're going to look at is the tangent secant exterior angle theorem. So in this case, exterior, and you see my angle is outside, on the outside of the circle. Right, in this case, we're going to say, I was just checking that I have it correct there, I'm going to write in my half already. Everywhere it's a half. So we don't forget about the half. And in this case, when it's exterior, let's take the first one. I have an arc again. So I'm going to start with this measurement of the arc from A to D. And this exterior one, I must subtract this. That's also, every time it's the part that is included by that angle, subtract the measurement of the arc B to D. And I'm done. Okay, in this case, here we had a tangent and a secant. Now two tangents, it's going to work exactly the same with two tangents. You're going to start with that outside arc that's not close to your angle, the measurement of BAD, indicating it's an arc. We always, when it's exterior, subtracting. And what are we subtracting? The one closer to the angle. So we're going to subtract the arc BD. Measurement of BD. And I need to close the parenthesis. Right. And in the last case, I'm sure you're picking up the method. Measurement of the one on the outside. It is a half of the measurement of AE. And AE is an arc. Subtract. And measurement of will be the small BD. BD. And it's an arc. And there we have it. Now let's just recap. Chords, half of, and the two arcs, plus. When there's an interior angle like this, and it's on your circumference, it's only the one arc, half of that arc, that is formed by this angle. By the angle, half of that arc. When it's exterior and we have two arcs, then the outside one, the measurement of the outside minus the inside one, half of it. Outside minus inside, half of that. Okay? We're going to take a look at some examples in the next video.